pretty, by the way. Let's talk about our next section. Parametric equations. Now, we know how to do equations of two types right now. So the first ones would be good old-fashioned Cartesian, right? That's what a curve looks like, y equals x squared. You then have polar equations. Remember all the fun we had yesterday drawing those on the graphs? That one would generate a spiral that actually goes on forever. And then there's a third and final way of doing equations, and they're called parametric equations. And a parametric equation is a very interesting form. We use the x and y coordinate system. But we tell you the x and y coordinate in terms of a variable called t. So let's show you what a parametric equation might look like. You might say x is t squared plus 1 and y is the sine of t. Now, thank goodness there is technology, but if you didn't have technology, because we're going to show how you do this the right way, or at least a quick way, is that you choose various values for t, and then you would find the x coordinate and the y coordinate using this formula. So for instance, when t is 0, the x coordinate is 1. When t is 1, the x coordinate is 2. And when t is 2, the x coordinate is 5. Now, when t is 0, the y coordinate is the sine of 0. And when t is 1, it's the sine of whatever 1 is, some decimal. And then it's the sine of 2. So can you imagine you could plot tons and tons of for different values of t, and you will get what we call the parametric equation. And so you plot it in the xy, right? And I could plot those 3 points, but if I did, wouldn't it be really hard to judge what the shape looks like? Because 3 points is not a lot. Wouldn't you have to do like 50 if you wanted to be detailed? But nobody's going to do 50 by hand. That just doesn't work. It's not practical. So Desmos does it for you. Now, this is how you do parametric. It's a strange format. You do a bracket. You do t squared plus 1, wasn't it? Yeah. Then you do a comma, and then you just do the sine of t, and you finish. Now, do you see underneath it automatically puts this? So I'm going to do it from 0 to, I don't know, 0 to 10. Right. Now, there's my curve. If I zoom out. And now I can see what it looks like. I might adjust the y values. And I'll make them -3 to +3. Desmos is good, but is that enough? Did I make a mistake there? Oh, I did. -3, 3. There we go. There. There, can you see the shape of it? It's quite an interesting, I don't know, is it like it's like a distorted sine curve, isn't it? I mean, some bits are squished and some bits are fat, and it doesn't quite, go up and down quite as smoothly as you want. Now, you can put in negative t values. It's totally okay. And oh, the shape takes on an even more interesting shape. Do you see how it looks back on itself? Now, you couldn't write down that curve using y equals anything, right? You know, if you do y equals x squared, don't you just get one value of y for every x, right? It's not going to happen. You could probably, don't know how, but you could have at least a fighting chance of maybe doing that as a polar curve, but I doubt it would even be possible. Can you see how parametric has got its own little niche market, right? Where it allows you to do certain curves that would be impossible using any other of the methods that we've got. Now I'm going to try a little, pretend I know what I'm drawing here. There. So I'll return back to, eventually, back to the white thing. There. So, kinds of questions that you're going to get are, here is a parametric, sketch it and tell me which one it is. Right? So, didn't I just put that one in? Okay, imagine there was 4 pictures and one looked like that and the other 3 didn't. Wouldn't you pick that one? So that's a pretty common question to be asked, right? Sketch it. Pay attention to the limits. If they say t greater than or equal to 0, do you see that little thing that appeared at the bottom that looked like this? You must put 0 in there. You can choose to put 10 or 5 or 50. But if they say that, right, you must put 0 in, right? Sometimes they will say that, in which case, isn't that what you should type in when you do Desmos, so that you get the whole picture? Because remember when I put in the positive, I only got this side. If I had used the one I've got, wouldn't I accidentally think, oh, I haven't got that shape? Well, the reason I haven't got that shape is I didn't choose the t interval that they gave me. So it's not cosmetic, it is important that you do that right. And there are 2 major questions. First one is, tell me what it looks like. That's going to be pretty quick. The second question, not so easy. And that is, how do you convert from parametric equations to Cartesian, or if you prefer, XY equations, right? So here is my parametric equation. And what we want to do is to combine this information so that I get a question, so I get an answer like y equals square root of t squared plus sine t. No, y equals the square root of x squared plus sine x, right? So if you can, try and make it a y equals function of x. But it isn't always going to be the case. If you can't make it y equals, will you at least make it, you know, like that, like x's and y's jumbled up? And maybe stick a y there, right? X's and y's all jumbled up. That's also going to be one of your goals. The next thing that makes this a little bit tricky is there can be more than one right answer. But one of the 2 answers is very often considered style points, a nicer version of the right answer. So can you imagine there might be a nice answer that's like 2 or 3 guys, and another alternate answer that's half a page and full of ugly square roots? You would want to pick the answer that looks nice. Agreed? It would make kind of easier to see what's going on. So let's go back to this question. How do you do it? Well, there are a number of techniques. Let me show you the first one. First technique is basically substitution. Look at one of the 2 equations and pick one that you can rewrite as t equals. Now I'm going to pick equation 1. And oh, by the way, t is greater than or equal to 0, right? So if I subtract 1 from both sides, I get that. So far, so good. What would I do to both sides next? How would I get t on its own?
Square root.
And since I said t is positive, do you notice I don't need to say plus or minus, right? I can just use the plus version. Now, so you do this bit. Now, this case, I've picked that one because I think that one's going to look prettier, right? But it doesn't matter. Sometimes you'll pick the y instead. but get it so that t is equal to that guy. And then substitute t equals the square root of x minus 1 into equation 2, or whatever the other equation is. If you use 2, then substitute it into 1, right? I've used 1, so I'm now going to substitute that result into 2. And we have y equals the sine of t, which now becomes y equals the square root of t. So far, so good?
Wait, why is it a square root t? Wouldn't it just be the square root of x minus?
Oh, aye. Did you all catch that deliberate mistake? See, I just let it hang there for a while because I'm useless at lying. That was just a mistake. Right. Now, I'm going to take that guy and go back to Desmos. And I haven't tried this before, so I hope it works. I'm going to do y equals the sine of square root of x take away 1 bracket. And there's a bracket there for some reason. X. It's not going to work. Come on. Now, do you see the blue curve? But there's no more red curve. Red curve, blue curve, red curve, blue curve. Doesn't that mean that they're the same curve? Haven't I verified that my equation works? So not every, by no means imagination, whatever, not every question or every parametric equation can be turned into Cartesian, right? There are many situations where it just ain't going to happen. But we're not going to ask you to do those ones, right? We're only going to ask you to do ones that can be converted, right? So it's not impossible for at least the ones we've given you. Now, I said that there is more than one answer, but sometimes there are two answers. And we prefer, when there is two answers, that you pick the one that looks pretty. Would you agree that that's pretty nice looking, right? Pretty smooth. Now, I'm going to return back to the parametric equation, and I'm going to show you the second version, which is the one we don't like. Now, if you start with y equals the sine of t, you can get t. What do you need to do to both sides to get t?
Inverse sine.
Okay, so if you take the inverse sine, that's cool. Now you can substitute t equals the inverse sine of y into, well, it's going to be equation 1, and you're going to get x equals the inverse sine of y squared plus 1. Right. Version 1 answer, version 2 answer. Would you agree version 1 wins the style point competition? And so we prefer you to do this answer rather than that one. Although mathematically that is correct, this is prettier. Now, in many questions, you won't have that option. In other words, there's only going to be one of the two that you can use to turn into t equals. And when that happens, then you don't have a problem, right? There's only one answer, and that's going to be the answer. Right? So let me show you one. That is a parametric equation. If I try to solve equation 2, this one here, the y one, wouldn't it be a non-starter? There's no way in the world you could ever make that t equals. You agree there's two t's and they don't play well together. It just ain't going to happen. On the other hand, wouldn't you have at least a fighting chance in making this one t equals? So you see in this case, there's only one that you can really work with. So let's see what that would look like. Now, it might mean that the answer is ugly, but it's the only answer in town, so it's right. As long as you do it to both sides, it's okay rule. Tell me what to do to both sides.
Add 4 and cube root it.
Oh, you did both in one go, thank you. Are we good? Add 4, take cube root of both sides. Now you go to equation 2, which is this one. And yep, the answer is going to be ugly as heck. And that's you finished, because I can't make that any prettier, but it's the right answer. So that technique that I'm using right now is the substitution technique, right? Find one equation that you can easily change into t equals, and then once you've done that, plug it into the other equation and you're done. But that's not the only way to do these. Sometimes you have to be, oops, I'm trying to find a question. Sometimes you have to be a little bit, what's the word? Trying to find an example of a trig one, where you have to just do it as a one-off. Try and be a little bit sneaky about how the substitution situation won't work for you. Now, there must be one. There we go, I finally found one. Took me a while. Question 5. X equals 2 sine t and y equals 2 cosine t. Now, whenever you see trig, sines, cosines, tans, don't do the substitution method. I mean, I could, get something like t equals the inverse sine x over 2, t equals the inverse cosine. Don't do it. They are correct, but they are the ugly answer. And we don't like the ugly answer. So we're going to try a totally different technique whenever there's trig involved. So here goes. I am going to square both sides. So x squared, 4 sine squared. I'm going to square both sides. So I'll call them my new equation 1 and my new equation 2. There is something I'm about to do next that's going to make the t's, the sine squares and the cos squared t's, disappear. And all I'll be left with is things with x's and y's. Any idea what I'm going to do to make that happen? How am I going to combine these? Last chance. Anything? Anything come to mind? Add them. If you add the two things on the left-hand side, you get that. And what happens if you add 4 sine squared to 4 cos squareds?
Sine squared plus cos squared equals
I'm quite sure what you said, but I think I know what you said. Isn't sine squared plus cos squared 1? So won't 4 sine squared plus 4 cos squared gets you 4? I think that's what you were saying. I'm going to catch it all. Hey, we're finished. Now, does that question have a y equals? Nope. But you can't always get y equals, right? Sometimes you just get mixed up x's and y's. And that actually, I recognize that. Isn't that a circle radius too? Try another one of these. I think question 6 is like it. It's 2 cosine t and y is 3 sine t. I'll call that equation 1. I'm going to call that guy equation 2. Now, if I just square these guys, it's not going to work. And the reason it's not going to work is this is going to be 4 cos squared, and this is going to be 9 sine squared. And don't you need the same number of sines and cosine squareds? So I'm going to do this first. I'm going to divide this side by 2, and I'm going to divide both sides here by 3. So essentially what I'm doing is I'm making sure I've got a sine and a cosine. I'll call them my new equation 1 and my new equation 2. Then I'm going to square each of these. So that's going to be x squared over 4 is cos squared. And I'm going to square both of these sides. So that's going to get me y squared over 9 equals sine squared. And now I can add them. And I have x squared over 4 plus y squared over 9 equals 1. And we are finished. Right, it's a mixed up x and y, but the t's are gone. That's what I need, right? X's and y's and no t's. It's pushing it, but somebody might know. Do you know what kind of curve that is? X squared over 9 plus y squared, x squared over 4 plus y squared over 9. If you've done astronomy, you'll have seen this shit. It's an ellipse. That's what an ellipse looks like. Any questions so far? The first bit is going to be easy, right? You plug it into Desmos and you see what it is and you pick from a set of 4 which curve looks like which guy. Now, whenever you have trig, this technique is one of the techniques you can use, but trig always has its own little variations on uniqueness that you have to deal with as it comes up. A cosine and a different cosine. There is no benefit to me squaring these things and trying to add them or subtract them or do anything with squares. So forget that technique, the one we just did for the last 2 questions. What we have to do instead is, and it depends on what you've got, what the next step's going to look like. But I'm going to focus on this fella.
Can you do the double angle formula without?
Yes, you can. Now, there are 3 double angle formulas, but only one of them is the right one to use in this particular situation. I'm seeing if I can find my double angle formula, which I may or may not have anymore. If you want to see Stokes theorem, these notes are no use to you. Okay, Delmar, I know what the double angle formula is. Which version of the double angle? I'll write them down for you. That way it'll give you time to think about it. One of them says that the cosine of 2t is equal to that. One of them says that the cosine of 2t can be written in that format. And the last one says it can be written in that format. Number 1, number 2, or number 3.
Number 2.
I like your answer because it's the right one. And I hope I'm going to like why you picked it rather than I guessed and I was lucky. So why that one and not?
Didn't add sign into there?
Yeah. You see this one has cosines, and so does that. See if this had said x equals sine t or x equals 10 sine t, right? So suppose it had said that, right? Then wouldn't I have chosen number 3? I can't think of when I would choose 1, so it's probably only going to be 2 or 3. Now that you've done that, and since x is cosine of t, won't this just become 2 cosines? Becomes 2x squared minus 1. Cool. Nothing to do with trig. Do a parametric equation with exponentials in it. I can think of at least 2 ways, maybe 3 if I pushed it to do this. Any suggestions? I mean, go for it. All you can do is do something that's wrong. I mean, you're not going to die. I trust you. You won't die if you get it wrong.
It reminds me of like using log. But
But
I don't know
you
if
can't think of what next to do, right?
like if you log
using log.
sides, you can use like, yeah, but I don't know that.
Okay, yeah, that is one of the 3 methods. So let's show you. If you use logs, say on the second or the first, what do you want to do? You want me to use logs on the first or the second?
Second.
I would choose the second. So what you get is the log of y equals t. And that means x can be written as e to the negative natural log of y. And it's nice, but it can be made better. It can be written as 1 over e to the natural log of y, which is nicer, but it can be made even better. What is e to the power of the natural log of y? It's actually something very simple.
Y.
Just y. And that looks even nicer. And I don't like fractions, so how about xy equals 1? Are you happy about xy equals 1 being the same thing? Yeah, we got it mixed up, x and y. Cool. Anybody got a different technique? Because that is a bang on technique. It works well, it's good. But can anybody see another technique? Last few seconds. Some other way of playing with this.
Wait, I'm sorry. Why did you put the x 1 over e to the natural log of y? Oh, wait.
Because a negative power becomes a 1 over a positive power.
Oh, okay.
Here's the trick. I'm going to multiply these together. So x times y should be e to the negative t times e to the t. So xy should be, well, e to the 0 xy is 1. And if you're wondering where e to the 0 is, when you multiply things together, don't you add the powers? So that's a different approach to the same question. Any others? Do you know what my third approach would have been? It would have been just to take x and do the same thing as that. Wasn't really that different than that approach. Right. Still on exponentials. There are at least 2 ways to do this. I guess there's 3 if you think of 2 of them as being essentially the same method in slightly different order. But I'm going to do the first method. I'm going to rewrite this guy as that guy. As an e to the 2t, just e to the t squared, right? It's just another way of looking at it. And since that is y, there's my answer. Isn't that kind of elegant? You don't always get y equals. I guess if I did want a y equals, wouldn't I do this? If I wanted it. And I think, let's see if we covered every possibility. Done. Okay, try this one. This is the last question that we're going to do, with the exception of I want to show you something that you need to do in Desmos, and then we'll be finished. So this is the last question where you convert it into xy's. Okay, all bets are off. You can pick any method you like. All I want is an x and a y when we're finished, right? No t's. Any suggestions how to work with this one?
I would want to put the first
Multiply?
equation into t equals, but I don't know.
Okay, so I want to put the first equation into t's. Well, if you want to do that, can't you use the as long as you do it to both sides it's okay rule? Great. So what should I do to both sides to get there?
Divide by 4 and then square root. So be square root of x over 2 plus or minus.
Great. And I should put a 4 there because the 2 isn't inside the square root anymore, right? Which is that guy. And so y will equal 8 plus or minus the square root of x over 2 cubed. Of course, if I tell you that x is greater than or equal to 0, can't we just remove the -1 and just keep a plus? If I tell you t is greater than 0, whatever. So you want to make this look pretty. It's 8, the square root of x cubed over 2 cubed. But 2 cubed is 8, so they cancel out, and all you're left with is that guy. Or that guy. It's the same thing. Now, the things that we've kind of left untouched, when you sketch a parametric curve, let's say it looks weird like that, there is what's called an orientation. Parametric curves have a direction, an orientation. They can go that way, or you could go the opposite way. And when you look at the pictures that they give you in WebAssign, you're almost always going to get two pictures that are the same, but the orientation is different. You're going to get one that looks like this, and the other, it's going to look like that. So you have to know which orientation is correct, right? Does it go along the curve this way, or does it go along the curve that way? Now, the way that you check orientation is find where the thing is at t equals 0, and then find out where the thing is at t equals 1. So you basically just do a couple of calculations. So I know this isn't, but can we pretend this guy was t squared plus 1 and y was 2t minus 1, right? Just for argument's sake. Right, at t equals 0 then, you would get 1 comma negative 1. And at t equals 1, you'd get 2 comma 1. And 1 negative 1 happened to be here. And 2 negative 1 happens to be here. Can you see from 0 to 1 tells me which direction to travel along the curve? And I like 0 and 1 because I'm lazy, and isn't 0 and 1 probably going to be the easiest to get the answer? Right. So just find out where it is at 0 and find out where it is at 1, and that will tell you that you're going, in this case, from here to there. So that's the way. Now, just for argument's sake, can you imagine that ended up being the point negative 1, 1, right? I'm not convinced that is the case, right? And that guy, forget the scale, wouldn't the thing be traveling this way then? Right? T equals 0 to t equals 1. Now, the next thing, they don't even give you a question, but it's loose ends. How do you convert the other way, right? That's a Cartesian, right, an XY. How do you make it parametric? It's so easy. It's not true. Don't you just make x equal t and y equal the formula? Won't that guy be him? So if I went and said to you, oh, make the parametric equation for sine x e to the x plus x, I would say, no problem. I'll make x equal t, and I will make y the sine of t plus e to the t plus t.